All right, this is the Geometry Unit 4 Lesson 3 video over what we call triangle congruence. And what this lesson and actually the next few lessons are all about is what amount of information is enough information to prove that two triangles are congruent. And so before we kind of jump right into that, there's some kind of terminology that we need to kind of know about. The first big idea is what we call corresponding parts. So when we say corresponding parts of triangles, we are referring to whenever I'm looking at two triangles. Say I have this orange triangle and this purple triangle. And let's say this is triangle MNO, and we'll call the orange triangle ABC. When we say corresponding parts of triangles, we're referring to the idea that when I look at two triangles, I want to kind of map them or map them onto each other or connect the parts that are in similar locations. So for instance, angle A in this corresponds with angle M in the purple triangle, because A and M are located around the same corner of those two triangles because they're oriented the same way. Also, I could say that, line segment NO, I should put that on the other side, line segment NO corresponds with, well, since NO is here, I would need this side right here. And so I would say BC. And you'll notice that when I named that side BC, I named it in the same order that I named NO. So because B is here and N is here, they came first. And then, of course, because C was here and O was here, they came second. So each letter needs to constantly kind of be paired with its twin from the other triangle. So this is what we mean when we say corresponding parts. So we're always going to be looking for corresponding parts of triangles. Now there are other examples. Angle B and angle N would be corresponding, or side AB and side MN would be corresponding. And then of course I could refer to the two triangles, and when I name them, I want to name them in a corresponding way. So if I said triangle ABC, I would say it corresponds with triangle MNO. It looks like an A. And so it's important that we kind of always have things together with their pair when we're talking about triangles. So that's one big kind of terminology thing we need to get around. The other thing is this idea of included sides or included angles, and all that means, and I'm just going to write that down before I draw it. But if we have what we call included, side, what we mean is if I have this triangle, call this triangle PQR, and I focus in on angle R and angle P, then the included side for angle P and angle R is side PR, because it's the side that has the place where those two angles kind of come together. So since R is like this and P is like this, then my included side would be PR. On the other hand, I also have this concept of included angles, and it's kind of the opposite idea. So to be an included angle, you might have a triangle, and we have maybe two sides. Say we'll call this triangle RST. And let's say I have side R, S, and side ST. And together their included angle would be angle S. So in terms of included, it just means the part that is kind of made up by or located inside of the other two things. So for included side, it's the side that's made up of those two angles. And for the angle, it's the angle that's made of those two sides. So RS and ST would come together to make angle S, whereas angle P and angle R would come together to make side PR. And so you kind of just need to keep that idea in mind. Those are some of the terminology we're going to come across. That's kind of what we've discussed up here at the top. Now, the rest of this is going to introduce different triangle congruence theorems. And I put a document in the classroom materials. If you go to classroom, just navigate here for you real quick. If you go to your classroom for geometry and you go to classwork and you look under Pro 3, there's a triangle congruence theorem. If you open that file, go ahead and close this. You've got two groups. You've got this top group, this grid, and then this list down below. But we're going to focus on this top grid first. Triangle congruence theorems are the ways we can prove that triangles are congruent. And really what it means is that there is only a certain type of information that we can have about two triangles to prove that they are congruent. For instance, just as an argument to show you what I mean. Let's say I have these two triangles. And all I know about them is that side AB and side MN are congruent. So we're saying that this side right here, this line segment and this line segment, which are part of triangles, are congruent. So really all I know is that these pairs of sides are congruent. Now, I haven't drawn the rest of the triangle because I want to point out the fact that this information about AB and MN, AB is congruent to MN. This is not enough information to prove that two triangles are congruent, because we can see that if I draw this triangle right here or this triangle right here, both of those contain that side, and yet those are two completely different triangles. So one side is not enough information to prove that two triangles are congruent. So let's look at the other side of that, and let's look at angles. I'm going to do a lot of racing here because I'm doing an explanation, and then we'll kind of summarize at the end. So again, let's say I have an angle. I'll say I know that this angle and this angle on two triangles are congruent. Okay, now I don't know how long these sides are. I just know that angle X and angle K, let's call it angle N, are the same. Like that. Let's do angle N. I know that they're congruent. So we know that angle X is congruent to angle N. So it's like, okay, well, is that enough information to prove that those triangles are congruent? In other words, is there only one triangle that I can create that has these angles? And it should be pretty clear that no, there are lots of other triangles. For instance, I could make a triangle like, oops, sorry about that. I could make a triangle like, maybe like this, right? Still has the angle that we talked about. But on the other hand, I could make a triangle like this. Look, this angle N and angle X are still the same. They're still exactly the same measure, and yet I've created two different triangles out of those angles. So one angle isn't enough information. So we've already seen that one thing, either a side or an angle, is not enough. And I'm not going to go through every example, but I will just do one more, which is to say, what if it's two sides? Okay, well, let's say I know that there's a triangle made up of a side length like this, and we'll call this AB and MN. And then we also know, and you're going to have to bear with me for a second, we also know, so those are congruent. We know that AB is congruent to MN. And we also know that there's another side of this triangle. I'll just make it really short. Let's say it's like this. Okay, this is AC. And without the, I'll get to this in a second. Let me draw this C as this O as well. So O, MNO, ABC. So we also know that AC is congruent to MO. Now, I've drawn this a certain way, but let me point out the fact that, like, let's say this triangle here is the way that it is, and the third side of this triangle goes something like this, right there. Okay, there's a triangle. Now I'm going to change something about this triangle in a minute. I'll show you what I mean. But let's say we have those two angles. Well, if I rotate this angle, this triangle, and I move it even just like that, now these two are still the same length. These sides, I've shrunk it too much. There we go. That does not look right. Let's go back here. Sorry about that. I did some shrinking I didn't mean to do. So now let's rotate. There we go. So let's say I rotate this. Now OM or AC and MO are still the same length. However, now if I draw my third side, I've got a different triangle. So two sides, side, that's not enough information either. So I'm going to spare you going through every single counter example. But I wanted you to see that these amounts of information, one part or two parts, is not sufficient. It's not enough to prove that triangles are congruent. So what is enough? How much information do I need to prove that two triangles are congruent? So I'm going to go through each of those examples. They're also listed here on the triangle congruence theorems page. So I'm just going to run through them, and they also are in your lesson. But the first is what we call the side theorem. Okay, side theorem says exactly what it sounds like. If I have a triangle with three sides, and there's another triangle that has those same three side lengths, there is only one possible triangle that I can make out of those three sides. I cannot contort this triangle any way. I can't do anything because those three side lengths are locked in. And so side is kind of the first and most obvious way to prove that two triangles are congruent. So if I can say that triangle MNO has all the same sides as triangle PQR, then I could say that those two triangles are congruent. So this is what we're going to be doing in this lesson, is saying, what is there enough information? And if so, what is the theorem that we used to prove that those triangles are congruent? So side is one of the appropriate ways to do that. All right, next we have side, angle, side. And I'm going to say something very particular about this A being in the middle of that. But if I have a triangle where the side, the angle, and the side are the same, then there's only one possible triangle that could be made out of those three. And so side, angle, side is another of the triangle congruence theorems. Notice it must be the included angle. Cannot be one of the other angles. It also says that on this page. It says here, side, angle, side, two sides and the angle between them are congruent. So for side, angle, side, it's got to be two sides and the included angle. So that is enough information to prove that two triangles are congruent. Let's keep going. Next one is angle, side, angle. Okay, should make sense. We have two angles. Say we have these two angles and the included side. There is only one triangle that can be made out of those combination of sides and angles. Angle, side, angle. Again, must be the included side, meaning the side that is between the two angles. And that is different from our last one, which is angle, angle, side. And so this is where I have two angles and another side. So again, two angles and another side. And so this is summarized here on the triangle congruence. These are the four triangle congruence theorems that you can use to prove that two triangles are congruent. And so in your lesson, they go through that same information. They give you an example of each one. And then let's look down at our questions and see what we need to do on these. So we have a lot of vocabulary starting with number 1 all the way through number 7. So you do the vocabulary questions there. I've gone over most of those words here. Numbers 8 through 11 are going to be about corresponding parts. So it says which side of DEF corresponds to BC on ABC. So we have triangle DEF and we have triangle ABC, and they want to know BC goes with what side on triangle DEF. And so you need to use what we talked about. So find what part goes with it. I'll kind of actually do this one for you. So really, if you take this triangle out, if you were to kind of like cut triangle DEF out of it, which side goes with BC? Right? So BC is this triangle here. Well, it's this vertical side right here, BC. So then BC would correspond with, we got to go in the same order, so it's going to be FE. Or EF. And so we see that's our answer right here. So which part corresponds? And because it's that vertical portion there on CB, it's going to be EF over here. So, all right. So that's through number 11. Number 12 and 13 and 14 are going to be proofs, including number 15. So I'll help you with those. And then I'll tell you what to do on 16 through the end. So let's go through the proofs together. I'll always complete the proofs on the video lessons for you, and you will not be responsible for them on the test. So here goes nothing. So they're going to take us through a simple proof of how to prove that two triangles are congruent. So I'm going to kind of talk us through this and hope that you kind of can grasp for the most part what's going on. So here they say we have triangle ABD and triangle DCB. We have the two triangles. You can see them here in the diagram. We also know that AB is congruent to DC, and we know that AD is congruent to BC. So we have that information right there. And they want us to prove the two triangles are congruent. Now we already know from what we talked about that two things is not enough. So we've already got a lack of information. We need more information to prove that these two triangles are congruent. So let's walk through the proof. First thing you need to know about proofs is that the reason for the first statement is always going to be what we call given. So we're going to choose answer choice D for that. So let's mark that guy out. The answer for the reason for part 1 is given. After that, we're just going to see what geometric properties are being used. It says in the second statement that BD is congruent to BD. So that's talking about this right here. So they're saying this is congruent to itself, which is great. That makes sense. BD is the same as itself. So that's pretty straightforward. But what property is that? Well, that's what we call the reflexive property. So anytime in geometry, when you say that two numbers are, or two values or two things are congruent to themselves, we call that the reflexive property. So we're going to go in here. And we're going to choose that as answer choice B. There it is. And that's going to be our answer for that one. Okay, so now if you look up here in our diagram, I see that we have sides, and another side in the middle. So I see that we have three sides that are congruent in these two triangles, which is why the answer for number 3 is side, side, side. The question is, what is the actual statement? Well, we know what the goal was. The goal was to prove that these two triangles were congruent right here. So that has to be statement number 3, ABD is congruent to DCB. That's going to be answer choice G. There it is right there. And that's what we get for this one. All right, so that is it for that proof. So let's move on to the next one. It's going to be very similar. We have information about these lines being parallel. AC and DF are parallel lines. That's these two lines here and here. Okay. We know that BC and DE are congruent. So that's this and this. Okay, and it looks like we're looking at these two triangles here and here. But let's kind of see what we got here. So we know those lines are parallel. We know that these two things are congruent. Obviously, given is our first statement. What are we given? Well, we're given this information right here. So that needs to go in statement number 1. Statement number 1, so that's going to be answer choice B. Always, the first thing is always the information you were given, and the reason is given. All right. So now we look at this. It says angle CBE is congruent to angle DEB. Let's look at that. Angle CEB, that's this one, is congruent to angle D. Oh, I did that backwards. Let's erase that. It says angle CBE is congruent to angle DEB. So hopefully you remember this from our last unit. This is a transversal line relationship, and those two are alternate interior angles. So if we go look at that, we'll see, if we go look at our answer choices, we'll see that that is going to be one of our answer choices right here in answer choice G. I should mark out this other answer. So looking at answer choice G, alternate interior angles theorem, that is our reason for number 2. Now we have something like we had in our last problem where we have something that is congruent to itself. That's going to be BE is congruent to BE. It's going to be right there in yellow. And so then that's going to be the reflexive property again. That's right here. Oh, there we go. Answer choice F goes right there. Now, if I come up here and look closely, I see that I have 2 sides and an angle in each triangle. I have sides, angles, and sides. So that's SAS. And you can see that that is what they're looking for in our last blank, is what is the property, what congruent statement did we use? Well, we didn't use side, side, side because we had an angle in there. And we didn't have 2 angles, we just had, let's see, where was it? We had an angle, a side here. We had an angle here. And we had up here in the original statement another side right here. And so it's going to be side, angle, side, which is answer choice D for number 4. All right. Good. So that's answer choice D. So let me mark that out. All right. Next one and last proof. They're going to walk us through. It's called a paragraph proof. It's just going to be more of like a description of what's happening. So it says MN is parallel to PO. MP is parallel to NO. Prove that the triangles are congruent. It says here, you are given information that, and let's go down here and look. Oh, that's going to be our givens. That's the very first piece of information that we're given is going to be those two. A, MN is congruent to PO. That's answer choice A. Since NP is a transversal cutting parallel segments, MN and PO, so we're saying this is a transversal line right here. MN and PO, you know that MNP and OPN are congruent, and that's going to be the same theorem as our previous proof. So it's going to be the alternate interior angle theorem. It's going to be answer choice I. Also, since NP is a transversal cutting parallel segments, you know that blank is congruent for the same reasons. So where's the other pair of alternate interior angles? Well, we already did this pair right here. We did MNP and OPN. Well, what about this other one? What about these pair? So that's the other pair of angles. So we have MPN and ONP. So that's going to be right here, answer choice E. So that's going to be for the same reason. And you know NP is congruent to MP, and we already know that. This is the third time we'll have done that in this lesson. That's the reflexive property. So it's going to be answer choice H. And then lastly, we can conclude that the two triangles are congruent, and that's going to be answer choice C. We know those two triangles are congruent because of ASA, because we had two angles and a side. And I'll show you that real quick. We have angle, 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 and the side in between. That's going to be angle, side, angle. All right, thanks for bearing with me on those proofs. Let's scroll down here and look at number 15. Several years ago, a popular bridge construction design was a rigid structure, V-leg design. The bridge here is supported by two triangle-shaped trusses, and you can see those are two triangles right there. We have triangle ABC and triangle DEF, and they are parallel segments cut by transversal AF. So it says here that B is congruent to E, B is congruent to E, and AC is congruent to DF. Do you have sufficient information to be able to prove that triangle ABC and DEF using the AAS theorem? The question is, do we have it? Well, we do. And the reason we have enough information is because we are using corresponding angles. We can either use these are corresponding angles, or we can say that these are corresponding angles in the transversal line. So we're going to use A and D are corresponding angles. There we go. So that's going to be your answer choice right there. All right. That's pretty much it for that one. I'll let you just take that answer from me. Now, starting at number 16, you have 4 questions, and they want to know which pair of triangles demonstrates a particular postulate of congruence. That's these 4. So each diagram, starting at number 16, each one of these diagrams goes with one of the postulates. So in this first one, which one goes with side, side, side? That should be pretty obvious. It's the only one of those diagrams that only has congruent sides. So you need to use the diagrams I gave you in the notes and the ones here on the triangle congruence theorem sheet to find which pair goes with each one. So this is what you are responsible for on the test. You need to be able to look at a diagram and know, based on the markings, which postulate it goes with. So go back and review my notes. Listen to the earlier part of the video if you need to, but that's what you do for 16, 17, 18, and 19. And that is the end of our video.